Imagine picking up your Android phone, unlocking the screen, and instead of just swiping through apps or notifications, you are suddenly staring at a fully functional Arch Linux desktop environment running locally on your device. No cloud streaming, no remote servers, no complicated rooting process, and no dangerous system modifications. Just pure Linux power living directly inside your phone. This is exactly what the new Android application called Local Desktop makes possible, and it represents a major shift in how we think about mobile computing, Linux accessibility, and the future of smartphones as real productivity machines. For years, Linux enthusiasts have dreamed about turning their phones into pocket-sized PCs, but the barriers were always high. Root access was required, security risks were unavoidable, performance was unreliable, and setup was often so complex that only advanced users could manage it. Local Desktop changes all of that by offering a clean, user-friendly way to run Arch Linux locally on Android without root, making this dream accessible to a much wider audience. To understand why this is such a big deal, we need to talk about the limitations of Android itself. Android is built on top of the Linux kernel, but it is heavily locked down. The userland is completely different from traditional Linux distributions. File system access is restricted, and applications are sandboxed for security. This is great for everyday users who want stability and safety, but it has always frustrated power users who know that their phone hardware is more than capable of running a full desktop operating system. Modern smartphones have multi-core CPUs, large amounts of RAM, fast storage, and powerful GPU. In many cases, the hardware rivals or even surpasses low-end laptops. Yet, the software experience remains limited to mobile apps. Local Desktop takes advantage of Android's existing capabilities, especially features like user space virtualization and containerization, to bypass these limitations in a safe and supported way. At its core, Local Desktop uses a Linux container approach rather than a full virtual machine. This is crucial because virtual machines typically require hardware-level virtualization support and deep system access, which is not available on standard Android devices without root. Containers, on the other hand, share the host kernel while isolating the user. Since Android already runs on a Linux kernel, Local Desktop can deploy an Arch Linux userland environment on top of it without touching system partitions or requiring elevated privileges. This approach keeps the Android system intact and secure while still providing a genuine Linux experience. You are not running a fake or stripped-down shell environment. You are running real Arch Linux with Pacman package management, rolling releases, and access to the vast Arch repositories. The setup process is surprisingly straightforward compared to older methods. Traditionally, running Linux on Android involved tools like CRUT environments, prut, or manual scripts, often combined with while powerful, these methods were fragile and intimidating for new users. Local Desktop wraps all of this complexity behind a clean interface. After installing the app from the Play Store or another trusted source, the user is guided through the initial setup. The app downloads the required Arch Linux-based system, configures the environment automatically, and prepares a desktop session that can be launched with a single tap. There is no need to unlock the bootloader, no flashing of images, and no risk of breaking your device. Everything happens in user space, respecting Android's security model. Once the environment is running, the experience feels remarkably close to using Arch Linux on a traditional PC. You get a standard file system layout, access to common utilities, and the ability to install almost any package you want. Whether you are a developer who needs compilers, interpreters, and build tools, or a power user who wants a full desktop with window managers and productivity software, the flexibility is there. Lightweight desktop environments like XFCE, LXQT, or even tiling window managers such as i3 or BSPWM work especially well on mobile hardware. With some tuning, performance can be surprisingly smooth, even on mid-range devices. One of the most impressive aspects of Local Desktop is how it handles the graphical interface. Running a Linux desktop on Android requires bridging the gap between Linux graphical stacks and Android's display system. Local Desktop typically uses a combination of a virtual display server and a client viewer to render the desktop inside an Android window. This might sound complex, but for the user it simply means that the Linux desktop appears as an app window that you can interact with, using touch, a mouse, or even a physical keyboard. Gesture support, scaling options, and resolution adjustments help adapt the desktop UI to small screens. When paired with a Bluetooth keyboard and mouse, or connected to an external display via USB-C, the phone truly starts to behave like a compact PC. The choice of Arch Linux is particularly important and symbolic. Arch is known for its simplicity, transparency, and user control. It does not hide complexity behind layers of abstraction, but instead gives users the tools to build exactly the system they want. For advanced users, this is a dream come true. You can customize every aspect of your environment, from the init system to the desktop appearance. But even beginners can benefit, especially with local desktop handling the initial setup. Once inside the environment, users can follow standard Arch documentation and tutorials, which are among the best in the Linux world. This also means that the system is always up to date. Arch's rolling release model ensures that you are running the latest software versions, something that is often difficult to achieve on mobile platforms. Security is another area where local desktop shines because it does not require root access. It does not weaken Android's security model. The Linux environment runs with normal app-level permissions, and Android sandboxing ensures that it cannot interfere with system components or other apps. This is a major improvement over older root-based solutions, which often expose devices to serious risks. For users who care about privacy and security, this approach strikes an excellent balance between power and safety. You get a full Linux system without compromising the integrity of your phone. Performance is always a concern when running desktop software on mobile hardware, but the results here are better than many might expect. Containers are lightweight, and because there is no full virtualization overhead, CPU and memory usage remain efficient. Of course, you are still limited by the hardware of your device, and running heavy applications like large IDs or browsers with many tabs can push the limits. However, for coding, scripting, light content creation, and system administration tasks, the performance is more than adequate. In some scenarios, it can even outperform older laptops, especially when using optimized, lightweight software. The implications of this technology go far beyond simple experimentation. For developers, local desktop can turn an Android phone into a portable development environment. Imagine writing code, compiling projects, or managing servers directly from your phone while traveling. For students, it can be an affordable way to learn Linux programming and system administration without needing a dedicated PC. For professionals, it opens up new workflows where a single device can serve both as a phone and a computer. This aligns perfectly with the broader trend of convergence, where the boundaries between mobile and desktop computing continue to blur. There is also a strong educational aspect to this. Learning Linux traditionally requires access to a PC, installing a distribution, and possibly dual booting or using virtual machines. With local desktop, anyone with an Android phone can explore Linux in a safe, reversible way. This lowers the barrier to entry significantly. Students can experiment freely, break things, fix them, and learn by doing, all without risking their main system. For regions where access to computers is limited but smartphones are common, this could be especially impactful. Of course, it is important to be realistic about the limitations. A phone is still a phone, and there are constraints related to screen size, battery life, and thermal performance. Running a Linux desktop continuously can drain the battery faster than normal usage, and sustained heavy workloads may cause the device to heat up. Multitasking between Android apps and the Linux environment also depends on the amount of RAM available. Older or low-end devices may struggle, and the experience will not match that of a high-end desktop PC. However, these are limitations of hardware, not of the concept itself, and hardware continues to improve rapidly. Another interesting aspect is how local desktop fits into the broader Linux on mobile ecosystem. We have seen projects like Ubuntu Touch Post Marquitos and Sailfish OS attempt to bring Linux to mobile devices by replacing Android entirely. While these projects are impressive, they often suffer from limited hardware support, missing drivers, and lack of mainstream app ecosystems. Local desktop takes a different approach by embracing Android rather than replacing it. You keep all your Android apps, your device support remains intact, and you gain Linux as an additional capability rather than a replacement. This hybrid model may prove to be more practical and appealing for most users. From a philosophical standpoint, local desktop also highlights the flexibility and power of Linux itself. The fact that the same operating system principles can scale from servers to desktops to smartphones speaks volumes about its design. Running Arch Linux on a phone without root access would have seemed impossible not long ago. Yet here we are. This is a testament to the creativity of developers and the open nature of the Linux ecosystem. It also shows how user-space technologies like containers can unlock new possibilities without requiring invasive system changes. As the app matures, there is plenty of room for further improvements. Better integration with Android features, improved GPU acceleration, more refined touch controls, and easier external display support could all enhance the experience. There is also potential for pre-configured profiles tailored to different use cases, such as development, education, or media consumption. Community involvement will likely play a big role here, especially given Arch Linux' strong user community. Feedback, contributions, and shared configurations can help refine the platform and make it even more accessible. For many users, the idea of running Arch Linux on a phone may sound niche or experimental, but it reflects a larger shift in computing. Smartphones are no longer just communication devices. They are powerful, general-purpose computers that happen to fit in your pocket. The software ecosystem is slowly catching up to this reality, and tools like local desktop are pushing the boundaries of what is possible. They challenge the assumption that mobile devices must be limited to mobile operating systems and show that with the right approach, we can have the best of both worlds. In practical terms, using local desktop can change how you think about your phone. It is no longer just a consumption device for social media and videos. It becomes a creation tool, a learning platform, and a serious computing environment. Whether you are compiling code on the go, writing documents, managing servers, or simply exploring Linux for fun, the possibilities are vast. And because everything runs locally, you are not dependent on an internet connection or external servers. Your data stays on your device under your control. In the end, local desktop is more than just an Android app. It is a proof of concept that demonstrates how flexible and powerful modern mobile devices and open source software can be when combined creatively. By allowing users to run Arch Linux locally on Android without root access, it removes long-standing barriers and opens the door to new workflows, new learning opportunities, and new ways of thinking about personal computing. As this technology continues to evolve, it may well play a key role in shaping the future of Linux on mobile devices and redefining what we expect from the devices we carry with us every day.